Alright, so the first thing we're going to learn about today is classifying triangles. And you have a little chart here, so we are going to use our highlighter and do some classifications. So the first type is an acute triangle. When you have an acute triangle, Ziggy, what do we know about an acute triangle?
The angles are going to be less than 90 degrees.
Okay, and how many of them are we going to have?
3.
Okay, so in an acute triangle, there are 3 acute angles. And like Ziggy said, if they're acute, we know that all of their angles are going to be less than 90 degrees. Okay, so all angles are less than 90 degrees. Okay, the next type is called equiangular. Can you guys say that with me? 1, 2, 3, equiangular. Okay, so if you break apart that word, the first part, equi, kind of sounds like what? Equal. And here they tell you that you are going to have 3 congruent acute angles. So not only do you have 3 acute angles, they're also congruent. They're also the same. Now, in a triangle, Emily, how many degrees do we have in a triangle? 3. How many degrees? But yeah, there are 3 angles, and then the total of all the angles would be, do you remember that? Yeah, 180. So if you have 180 degrees in one triangle with 3 angles, if you take 180 and divide by 3, it's like 18 divided by 3. What's 18 divided by 3? 6. So each angle has to be 60 degrees. Okay, so 3 congruent acute angles, they would all be 60 degrees. Another way you'll see them marked in the diagram is with this. Okay, so this is like 1 slash here. They each have 1 slash. They're showing you that they're congruent. Okay, so they would all be 60 degrees there. Then we have a right triangle. And Nate, what do we need to make a right triangle?
One side needs to be 90 degrees.
You said side, but you meant what?
Oh, I meant angle.
Yeah, and you only need, like you said, you only need 1 right angle. Now, when you're looking at your picture, Nate, how do they show you that you have a right angle?
With the box.
Yes, okay, so you'll have this little square here saying, yes, this is a right angle. Think about why it makes sense that you'd only have 1. If you had 2, what would the degree be? 180. And would we have a triangle if we had 2 angles that added up to 180? No. Okay, you wouldn't be able to have your third angle. The next one is obtuse. And Nia, if we have an obtuse triangle, what do we know about the angles?
They're equal to more than 90 degrees, but less than 180.
Okay, and how many of those obtuse angles are we going to have in our triangle? No. So what does it say?
Oh, 1.
Yes. Okay, and let's talk about why that makes sense. So if you had more than 1 angle that was bigger than 90, that means those 2 together would be more than 180. And then if it's bigger than 180, it can't be a triangle. Okay, so your triangle is always going to have 180 degrees in it. So you're only going to have 1 angle that's greater than 90 and less than 180. Okay, so you're going to have 1 obtuse angle, and this one, it's this angle here. Okay, so you're going to have 1 angle that is greater than 90 degrees and then less than 180. Okay, and then the other 2 would have to be what type of angles? Have to be acute, right? All right, so for our first example, we are going to classify the triangles by their angle measures. So we have to look at what triangle they're talking about. Because if you look at the triangles here, how many are there in that picture? There's more than 2. There's 3, right? So there's this one, the ABD, there's BDC, and there's ADC. Okay? So there are multiple triangles in here. Sometimes what I'll do is I'll just highlight. So if I'm looking at BDC, I'm going to highlight what that angle is, or what the triangle is. All right, so in BDC, let's pick out what our angles are. And I'm just going to draw just a rough sketch of this here. So I can see that this is 10 degrees. The 90 degrees is for the whole angle, but I don't have that whole angle. I only have part of it, so I don't know what that is. Well, actually, I do. This tells you that this is 20. If this is 20, then Sarah, what does this angle have to be? So if this little piece here is 20, and you know it's a right angle, then this piece has to be what? 70. Yes. Okay, so this angle here is going to be 70 degrees, and then they tell you that this angle is 100 degrees. Okay, so then Ashna, what type of triangle do I have? Acute, equiangular, right, or obtuse? Good, how do you know? Yes, so you have one angle that's obtuse, you have one angle that's greater than 90, and less than 180, so it's going to be an obtuse triangle. So we are going to write obtuse, and then we are just going to write y underneath it. Okay, and that's because angle, and this angle here is called angle DBC, is obtuse. It's 100 degrees. Okay, so it is greater than 90, less than 180. So that's what you're looking for. All right, and then the next one we're going to look at is ABD. Okay, so ABD is this little triangle next to it. Okay, so if I want to draw a picture of ABD, I can label all of its angles. So this is showing me here, this is 20. Okay, this one here is showing me that this is 80 degrees. Now, if this angle is 100, Jillian, how can I pick out what this angle is next to it?
You can minus 100 by 80, or 80 by 100.
Say it again. So you can subtract
Which angle is it?
this one.
Oh,
I think you know it. I think you just said it wrong, right? These two angles together have to add up to what?
180.
Yeah, 180. So then you would subtract 100 from 180, and you would get that that one is 80. You could also, if you know these two angles, right? If you know what these two angles are, you know the third one has to make this so that it's 180. So 80 plus 20 is 100. 100 minus 80 would be 80. Okay, so then Rhea, what type of triangle is this going to be?
Obtuse. Oh, not obtuse.
That's all right.
Acute.
Okay, and then tell me why.
Because all of the angles are less than 90 degrees.
Okay, good. So this is going to be acute because all angles are less than 90 degrees. Okay, and in addition to that, in addition to them being less than 90, they also are not equal. Okay, so all angles are less than 90 and are not equal. Okay, because if they are acute and equal, then it is going to be equiangular. So again, you can figure out that missing angle two ways. So if you know they're 80 and 20, right? 80 degrees plus 20 degrees plus the measure of angle ABD would equal 180. So if we subtract 100 from both sides, that's how we found the measure of ABD. Okay, so you do have to know what every angle is in order to properly classify it. Uh-huh.
In the notes, like for A, what does it say before B, before D, C? Like it's like something is less than.
Oh, because angle DBC is obtuse. Yes. Yeah, because angle DBC is obtuse. All right. Now, in addition to classifying triangles by their angles, even though this is kind of blurred out, you can also classify them by their, let's write it on top, side lengths. Okay, so the first thing we were doing is classifying by their angle measures. Let's actually write angle measures here. Okay, so you can classify a triangle by its angles, or you can classify a triangle by its sides. So the first type we have is an equilateral triangle. And Matt, how do we know if we have an equilateral triangle?
All the sides are congruent.
Good. So if it's equilateral, all three sides are congruent. Now, if you're looking at a picture, Allie, how are we going to tell from the picture that they're congruent? Yeah, so it's going to depend on the number of lines on each side. So each of these sides have one line. That's one way you can show it's congruent. The other way you might see it is they might actually give you the side lengths, and then you'd see that the side lengths are the same. Okay, so the second type is isosceles. And Elizabeth, if it's isosceles, what is our situation that we have? Okay, so there's at least two congruent sides. Okay, and again, those can be shown using your tick marks. So here, notice how there are two on each side. So that means those two sides are congruent to each other. And then the last one is scalene. Okay, and then CJ, if it's scalene, what do we have? Right, okay, so none of the sides are congruent. So no congruent sides. Okay, so you won't see any marks there, or you could be given the side lengths and all the side lengths would be different. Yes?
Is that, like, for the, up there, does that mean, like, an equilateral triangle? Is that isosceles triangle? It says that next. Like, can it also be?
Yes, yeah. So when you classify them, if they have two sides only, you'll call it isosceles. If it does have the three sides, you will say it's equilateral. But technically, this would be equilateral and isosceles because you have at least two of them. So for the next one, we are going to classify by the side lengths only. And we're going to use a similar process that we did before, except now, instead of writing out the angle measures, we're going to be writing out your side lengths. So the first one we have is EHF. So remember I said I just like to outline EHF. Okay, so I know what I have here. So this is your E, your H, your F. And then this side we're given is 12. This part we're given is 10. And then we also have this tick mark here. And we have this tick mark here. So, Kira, what do the tick marks mean? That they're equal. So then if this is 10, this has to be 10. So then, Kira, what type of triangle do we have? Isosceles. So this one is going to be isosceles. We're going to label that. And it's because you have two congruent sides. Okay, so two congruent sides. Okay, and then we're going to look at EHG. Okay, so for EHG, that is this whole triangle here. So I'm just going to label what my sides are. Okay, so Anakin, what's my EH length?
EH,
Yep,
12.
12. What about HG?
HG's 11.
And EG?
10.
Nope.
14.
Yes, good. Okay, and how'd you get 14? How'd you get it?
By adding the both of the EF.
Okay, good. So EF is 10, FG is 4, so we do have to add them together to get 14. Okay, and then Abigail, based on your side lengths, this is going to be what type of triangle? Good, okay, so it's going to be scaling because all of your side lengths are different. Okay, so that's going to be scaling. Okay, so all side lengths are different. Do you guys remember talking about scaling and isosceles triangles when you were younger? Alright. So now what we're going to do is we are going to use this classification to help us find side lengths of the triangle. So remember I said we're just going to concentrate too on making sure we're following directions. So we're going to highlight our directions. So this is to find the side lengths of the triangle. So that means, Naomi, how many different answers am I going to have for this? 3, because I have 3 sides. So if I'm finding the side lengths, okay, that means I have to find all 3 sides of the triangle, okay? So when you look at your triangle, you want to notice if any sides are congruent. Because if we have congruent sides, Ella, what could we do with those sides? Yes, okay, great. So when I'm looking at my picture, Christina, what 2 sides are marked as congruent? That. Wait, so when you name the side, tell me with the 2 points. Yes, sorry, will you say it again? I just couldn't hear you. 4x minus 2.7. Okay, yep, so then this side would be JK. So side JK, yep. And then that would be congruent to what side, Christina? Good. Okay, so if we know those are congruent, based on the definition of congruent sides, I know that the measures are equal. So I can go ahead and I can plug in 4x minus 10.7 for JK and set that equal to 2x plus 6.3 for KL. All right, so then when I do this, what I'm keeping in mind is my first step is going to be to solve for x. But if I'm finding the side length, Rachel, after I solve for x, what am I going to have to do? Yes, okay, so you're going to have to substitute the x value into each expression to find the side lengths. And we'll talk about some shortcuts to that as well, and how to check. So you'll have to find all 3 sides, so you want to substitute your x's in there. All right, now we're going to do this without a calculator because you don't need it. The first thing, Clara, you're going to do is what? And then so what did you combine first? Good. Yep. Okay, good. So when you subtract the 2x, the x's will cancel out here. 4x minus 2x is going to be 2x. And then like Clara said, we can also add the 10.7 over at the same time. Now when you're adding these, see how you have 0.3 and 0.7? What's 0.3 plus 0.7? 1. It makes a whole, right? So if you add this up, Max, what are you going to get when you add those together? Okay, because you did 10 plus 6, which was 16, and then the 0.3 plus 7, which was 1, so it would be 17. And then, Max, how am I going to finish this? What am I going to do after that?
You're going to divide 17 by 2.
Okay, so I'm going to divide both sides by 2. So x would be 17 divided by 2, which we can cut that in half. So when you cut it in half, think of what's half of 16? 8. So if it's half of one more, it would be half. Okay, so this would be 8.5. All right, so that's our first step, is to solve for x. Now we're going to substitute. Now, when you substitute these in, remember that JK and KL are what? Congruent. So then when I plug these in, JK and KL should be the same. So when you do this, I do think it's a great idea to plug it in for both to make sure you get the same answer. But you should also know, okay, when you have JK, that should also be your KL. I'll show you how to do this one without a calculator too. So if it's 4 times 8.5, you can just do 4 times 8, which is what? 32. And then you can just add it to 4 times a half. What's half of 4? 2. So this is just 34 minus 10.7. So when I do this in my head, the first thing I do is take away 10, which is, what's 34 minus 10? 24. And then if you minus 0.7, just think about what adds to 0.7 that would give you a whole number. Yep, and then you would just go down 1. So this would be 23.3. Okay, so that's your length for JK. Make sure that you do label which one it is. Okay, so you have to tell me what side it is. Let's verify that KL, we get the same thing. So 2 times 8.5. See how that's a nice decimal that you can do in your head? Because 2 times 8 is 16. 2 times a half would be 1. So together it would be 17. Now, when you are adding 6, this is how I think of it. I try to get to my next whole number. So what's my next whole number after 17? It'd be, or your next, yeah, 20. That ends in a 0. So I would need to take 3 to get to 20. So this would be 23.3. And that is your KL. So good. Those ended up being the same. And then the last one is JL. So 5 times 8.5 plus 2. You guys think you could do this one without your calculator? So remember, you can do 5 times 8, which is 40. What's half of 5? 2.5. So it's just 40 plus 2.5 plus 2. So 42.5 plus 2 would be 44.5. And this would be your JL. All right. Now, for the next thing, we have an application. Good. Part of it got cut off, so I wrote it in. So hopefully that worked out. So we have a steel mill that produces roof supports by welding pieces of steel beams into equilateral triangles. Each side of the triangle is 18 feet long. How many triangles can be formed from the 420 feet of steel beam? Now, I've noticed when there are a lot of words, people get scared and abandon the problem. Okay, so what we're going to do is we're just going to break it down into manageable pieces. So one important piece of information is our shape. And Josie, what was the shape of your steel beams? Yep, what type of triangles? Good, okay, so if they're equilateral triangles, then we have to know, Griffin, what's special about equilateral triangles. Okay, so if it's equilateral, you have 3 of the same sides, okay? Or all sides are congruent. Okay, so all the sides are congruent. That's going to be important. Ethan, what else is going to be an important piece of information here? Okay, good. So each side of your triangle is 18 feet long. So what I would do is I would start to draw a picture. So I know it's equilateral, so all of these are the same. Each side is 18 feet, so I can label, all right, this is 18 feet, this is 18 feet. And anytime you have your units given, you are going to include those in your final answer. So another important thing is the question, is what are you trying to do? And Adele, what are we trying to do for this problem? Good. So we have to find how many triangles. Okay, that's going to be our final answers. The number of triangles that can be formed from 420 feet of steel beam. Well, in order to figure out how many triangles can be formed, we have to know how much it takes to make one triangle. Okay, so Danielle, how can I figure that out? So if I know each side is 18 feet, how can I find out how much I would need for one triangle? That's not going to help you with one triangle. That would be how many sides you can make from 420. But just looking at this triangle, how can I figure out how much feet I need to make just your one triangle? Yeah, right? So add each side up, right? Which is going to be 18 times 3, so you have 3 sides of 18. Okay, again, this is something else you can do without your calculator. You can do 3 times 10, which is 30, and then 3 times 8, which is 24. So 30 plus 24 will be 54. Okay, so we have 54 feet of steel that's required for one triangle. Okay, now remember, we're going to have to figure out how many we can make total, which I think is what Danielle was leading to. Yeah, Rhea, you want to tell me how you do it?
Divide 420 by 54.
Okay, so you're going to take the total amount of steel that you have, divide it by the steel you need for one triangle. So your total amount is 420 feet. Okay, that's your supply. To make one triangle, it would be 54 feet. Okay, so we're going to divide that. Okay, and you can use your calculator to do that. When you are dividing it, can you guys estimate about how much it will be? You see how this is almost about 50? This is a little bit more than 400, right? How many times does 50 go into 400? About 8. About 8, right? So it should be somewhere around 8 when you do this. Okay? And you can also reduce like your fraction. You could make it a reduced fraction. You could keep reducing. So when you divide, you get 7.7 repeating. So just pay attention to, like if you had this on a test or quiz, if it didn't tell you what to round to, then what you would say is round it to whatever place you want, but it would have to be correct. Okay, so this would be like 7.7 repeating. Now, when it asks you how many triangles can be formed, can you have 0.7 of a triangle? No. So if they're asking you how many whole triangles you can make, are we going to round down or round up? Down. Okay. So therefore we can make, oh, do you guys know the symbol for therefore in math? It's these 3 circles. So this means therefore we can make 7 triangles from 420 feet of steel. All right. And then I'm going to let you start on your homework. So on page 219. Your section is 4.1. You're going to do 12 through 32, 41 through 44, 55 through 58. Okay, and then I'm going to put up your key in Google Classroom so you can check with your key. So when I check your textbook work, I'm going to look to see that it's corrected. So when you correct it, use some kind of correcting pen. Okay, and I want you to write in the correct answers. Okay, and then if you have time, I would go back over the ones that you got wrong and see if you can figure out what you got wrong. If you're having trouble figuring that out by yourself, then that's definitely one we should go over in class together.